Introduction to Electromagnetism. Electromagnetism is a fundamental force in physics that can be observed in electric currents, magnetic fields, and electromagnetic waves. Electromagnetism is the study of this force and how it interacts with other forces. In the 1800s, Michael Faraday discovered the law of induction. In the presence of a magnetic field, there is an induced current in a loop of wire when a changing magnetic field is applied to it. This law was used to generate electricity with generators that use rotating coils. In order to understand this law, it is helpful to know how a transformer works. A transformer using alternating current is made of two coils of wire connected in parallel. The primary coil has many turns of wire wrapped around an iron core, and the secondary coil is wrapped around the outside. When a voltage source, such as a battery or an AC power source, sets up a magnetic field across the primary coil, there will be an induced current in the secondary coil. For a transformer working with direct current, the two coils are connected in series. When this current is passed through a load such as an electric motor, it becomes alternating current. Direct current is not compatible with alternating current, and so the two currents must be converted to each other. Transformers work with alternating current. The primary and secondary coils are connected in parallel. Alternating current can be converted to direct current by running it through a rectifier circuit. Windings that are interconnected in series produce a combined current that flows through both windings. The induced current in the secondary coil will flow through both windings of wire. In this case, there is no difference between DC and AC currents. The current that flows through the primary coil is at a specific voltage, typically around 120 or 240 volts. And the current that flows through the secondary coil is a direct result of how much current has been induced in it by the primary coil. The magnetic field induces a voltage in each conductor of the secondary wire, causing an alternating current to flow. The way this alternating current changes direction depends on whether you are using AC or DC power. If you use AC power, then each conductor will be changing its voltage 60 times per second, and if you use DC power, then the change in direction will be 120 times per second. This alternating current eventually changes back to a steady state as the voltage changes in each conductor of the secondary wire. A transformer is one method used to convert AC power into DC power. The primary coil is magnetized around its axis by an external electromagnet. And a current is passed through it from source that produces AC power, such as a wall outlet, so that it induces a voltage in the secondary coil. When the current changes direction, it induces a voltage across the two wires of the secondary coil. The history of electromagnetism. Electromagnetism is a fundamental force of nature that has been studied by various people for centuries. It was first discovered by the ancient Greeks, who observed that a magnetic rock could attract iron. In the 18th century, the early days of electromagnetism were studied by Benjamin Franklin and Alessandro Volta. Although it was not their intention, they discovered an electric circuit and a battery, respectively. In the 1800s, Michael Faraday investigated electromagnetism in more detail and created the first electric motor. In recent years, there have been many advances in electromagnetism, such as sending messages through the air using microwaves or using electricity to create light. Michael Faraday, 1831 to 1895, was an English scientist, was the first to produce and use electric generators. The first to understand electricity's fundamental relationship with magnetism, and the first to show that an electric current creates a magnetic field. Faraday also established important principles such as induction and electromagnetic induction, which are the foundations of modern electromagnetism and electronics. Faraday's law of induction is one of the most fundamental laws in physics, and it is named after him. It states that an electric current creates a magnetic field. This was a key discovery for Faraday, who also showed that an electric current can induce a magnetic field in another nearby conductor. The law of induction explains how electromagnetic fields propagate in space, as well as providing the means for generating such fields. In addition to Faraday's discoveries about electromagnetism, he also formulated a law of electrolysis. Faraday used the term magnetic field to describe the electromagnetic force in space that behaves like a magnetic field. A British thinker and scientist, Faraday is considered one of the pioneers of electromagnetism, optics and electrochemistry. He discovered electromagnetic induction, the principle behind most generators, and the laws, which govern it while investigating how to produce static electricity from chemical reactions. He thus contributed significantly to modern electrochemistry, the theory of electromagnetic induction, optics, and many other fields. Faraday also laid the foundation for the concept of the electromagnetic field by identifying the lines, magnetic field, surrounding a magnet. Michael Faraday was born in Newington Butts, which is now part of the London borough of Southwark but was then a rural area just outside London. His family had been in England for 3 generations, and his earliest American ancestor emigrated to Massachusetts shortly after the 1630s. Michael Faraday's paternal grandmother, Elizabeth Huxtable Faraday, was an heiress of one of the most prominent families in Philadelphia. Faraday attended St. George's School as a day scholar. His mother did not approve of the clothing worn by the other boys at the school and forbade him to go. His defiance, combined with his own fascination with science, enraged her further, and Faraday was only allowed to return when he was old enough to earn money for his own clothes. In 1823 he attended a local day school in Chertsey, now known as Chertsey Bridge, where he discovered a passion for chemistry and physics. He created ingenious experiments involving magnets and electricity, and later devised a lens dynamo for use in electric telegraphs. In 1827 he began to study at the nearby Royal Military Academy, Woolwich. In 1832, Faraday entered the Royal Institution of Great Britain, precursor of today's Royal Society, in London as an apprentice to its director, Michael Faraday. In 1834, he received his first honorary doctorate from the University of Glasgow, and in 1845 another from Oxford. From 1841 to 1845 he was in charge of the Royal Institution's extensive publication program. In 1845, he discovered that an electric current creates electromagnetic field around it and used this fact to develop the first ever magneto-electric generator. This device converted mechanical energy into electricity at a remote site. Faraday is also credited with the discovery of electromagnetic induction in 1831 and the law of electrical circuits in 1833. Faraday went on to discover benzene, palladium chloride, hexamethylphosphoramide, and diamagnetism. He's the only British scientist to have been awarded a Nobel Prize for his labors in physics. Electromagnetism is the basic theory of electricity and magnetism in physics. It explains how electric charges create magnetic fields and how moving electric charges and changing magnetic fields generate electromagnetic waves. Electromagnetism is one of the 4 fundamental forces of nature, alongside gravity, the strong nuclear force, and the weak nuclear force. The word electromagnetism was coined by British physicist Michael Faraday in 1831. He built the first electromagnetic generator or dynamo, such as a piece of laboratory equipment, from being exposed to external electromagnetic fields. A mutual inductance is the product of 2 inductors that are either across the same axis or in series with each other. It is calculated by multiplying the number of turns in one coil by its length and dividing by the number of turns in another coil. For example, if 2 coils have 100 turns each and are in parallel, the mutual inductance is 100 by 1. This can also be stated as a pair of inductors have a mutual inductance of 1. An impedance is a measure of the degree to which an AC source impedes current flow in a circuit. It is the ratio of voltage to current in a circuit. It is also referred to as resistance because it opposes the flow of current. What is a resistor? A resistor is a component that creates an electrical circuit that resists or impedes current flow. As such, it can be thought of as an electronic component used to resist the flow of current. As such, it can be thought of as an electronic component used to resist the flow of current through a conducting material in order to produce heat and a voltage drop. A resistor has an impedance that makes it harder for current to flow through it than through other components in the circuit and impedes or resists voltage. Thank you for watching part 1 of the secrets of the electromagnetism and how does it work, and don't forget to subscribe to my channel, please.